Our autonomous vehicle uses a small computer as its brain, basically the Raspberry Pi 4 Model B. And, it fits in your hand, it fits in the car. It's really, really cool. And it's got a lot of interesting features. So in terms of that, we're probably using the 4 GB of RAM. It's got Gigabit Ethernet. It's got USB 3, USB 2. It's got 2 monitor supports and has USB power supply and a fancy new processor, of course. So these things are really great. And they're basically the motherboard of a computer with all the peripherals attached. And we're going to use those to connect up all of the features of our autonomous vehicle. But as you can see, it actually supports dual 4K outputs. It's a real computer, so it's very powerful and very fun. So anyway, it's really neat. And at that point here, this is what we're going to do. So what do we got to do for that is we've got to sort of find its hard drive. Well, its hard drive is an actual SD card. And that's where, we picked our hardware, but we need some software to go with it. So we have the Raspberry Pi OS, and that's the operating system that we're using. It's a Debian Linux flavored OS, so it's actually got Unix commands, and it's got a GUI interface, and it's super flexible. Again, I'm just so excited. I'm just going to use super all the time. Anyway, so what we're going to do is we're going to have to pick the operating system for it. So it's not going to be Windows, and it's not going to be some big giant thing. This is actually going to be, we're going to pick, instead of recommended, we're going to go with Raspberry Pi OS with desktop. So we got the desktop stuff, all that together, and the download is 1.1 gigs. So that's pretty darn small for a pretty big system. So Windows is like 10 gigs or more just to get started. So this is tiny and robust, and that's kind of what we need. We need something inexpensive that we don't worry about breaking, and we can just replace as needed and let us do some experiments. So we would just run over here to download, and it would get you like the image for it, but I'm going to show a little bit easier way, because what we want to do is be able to make our own image and potentially make copies of that. So I'm looking through here. It shows all these different options. Like if you're into retro gaming, you can actually download the Retro Pi version of this. That's really cool. But what I'm really looking for is the Raspberry Pi Imager. The Raspberry Pi Imager allows you to write to the micro SD card the operating system, and it does it really in a fun, fast way. So here's like download for Windows so that you can use it. So if I download for Windows, I'll just click here and it'll grab me the imager. And what it does is allows you to choose the version of the OS and choose the SD card you want to write to, and then it asks you to write it, and it works out really pretty nicely. And to just show this off a little bit, they have like the how to use the Raspberry Pi Imager. So that was pretty fast, but that was pretty cool. So that's pretty much the deal. We just get that image, and actually if you have Raspberry Pi, you can do it on the Raspberry Pi as well. So anyway, that's the deal. We want to get that image, and once we get that image, we actually put it into the Raspberry Pi, and then we boot up to it, and we got to do a few things. However, we're doing something a little bit more than just booting up the Pi and running it like a computer. We're actually putting it in the autonomous vehicle. And if you look at the vehicle, you'll notice that it doesn't have a monitor. Since it doesn't have a monitor, we're going to have to do something we call run headless. So it thinks of the monitor as a head, and if you take the head off, it's running headless. So I'll just do Raspberry Pi headless. And yeah, there's a bunch of resources, including the Raspberry Pi site for this. And this is one of my go-tos is up here. And I'm just going to run through. We get that SD card. And when you take the SD card and you create it with the imager, it makes a boot folder, and that boot folder mounts onto Mac, Linux, and Windows and called boot. So you can actually find it attached to the operating system. So if I click here, the boot folder has a bunch of contents, and we don't really, we're not going to mess with the contents of the boot folder except for these two pieces. We're going to need to create a file called ssh.txt, and we need a file called wpa-supplicant.conf. So SSH stands for secure shell. So let's go up. So what is secure shell real quick? So it's a cryptographic network structure for operating network services securely over an unsecured network. Well, long story short, it's the command line with an encrypted connection. So this is something that works as a way to get access to a remote computer, not through the GUI or the the visual part of the operating system. It's actually a way to get there through the text part of the operating system. So this is super important for us because it's like the emergency backdoor. So like if the Pi freezes up, you could use SSH, log into the computer and reboot it. So it's a very handy tool. If you were doing races and things and you wanted to quickly get on something without an overhead of a lot of graphical data going over network, Secure Shell is really, really good. So I'll just click here. So Secure Shell just looks like a little text interface like this, and it says over here is PuTTY. So just for Windows users, if you're trying to get Secure Shell on your computer, sometimes it's built in under Windows 10, but if it's not built in, you can just go over and grab this program called PuTTY and download it, and PuTTY lets you talk to remote computers through a text interface, which is super awesome. All right. Then the next part is WPA supplicant. This is actually a little like, what is it? You get even a more technical name. So this is to configure the wireless network settings, which is really important because we're running headless. So we need to tell it what network it is on, and it's most likely your home network. So that's something we need to think about ahead of time, is like, well, what's your home network SSID and password? So we gotta get that information, and that needs to be there. So like if I was to get my home network info, I'd be looking around for like, oh, what's my home network? Well, it's called Dog Eden 5G, and then it has a password. So I'm like, okay, let me get that information and hold on to it. I'll back up here back to the Raspberry Pi headless information, and this is the information here. This little piece of information needs to go inside the WPA supplicant. Let's pop over and see. This one says new lines. Oh, new lines are just new lines, the end of the lines. Okay, but what I wanted to do was the more information on WPA supplicant. Okay, here we go. So there's a lot more detail. If we have to go through and do everything by hand, here, plenty of info to do that with. So in my case, I actually just I'm going to be a little more, I'm going to dig up just a teeny bit more detail here. Like, it's out of Wikipedia entry. So we're like, what the heck is it? It's basically available for everybody and it implements wireless connectivity. But it's the configuration that we're doing. WPA software. What I wanted was, what does WPA stand for? So everything, of course, has a standard. So we found the WPA supplicant support. Oh my goodness. So anyway, we went down all the way to the internet standard for what WPA supplicant is. And I can't spell either. It's the Wi-Fi specification. Let's see if we get a little bit better information over here. So it's a little daemon that runs on your computer. It tells you how to log into all the stuff. All right, well, I'm totally sidetracked. But there is WPA is a piece of software. Wireless WPA stands for, good gosh, Wi-Fi protected access. Whew. Okay, WPA, Wi-Fi protected access, WPA2. There's a WPA3 up and coming. But there we go. So this is This is the encryption part. That's right. It's the SSID and a password, and it encrypts your network communications. And the supplicant is a tool that allows the computer to interpret that information and put it on your Raspberry Pi dynamically. Whoa. Okay. So that was kind of a big detour, but all right, let's click on back. So this is actually nice because we can cut and paste it into a file. And I recommend a program called VS Code. You can just type in the word code and it just pops right up if you've got it installed. And you hit Control N for a new file. You can use Notepad for this as well, but I like that. So what I want to do is grab this and do a quick edit. So the edit that I'm going to do is just going to show how this works. So I'll paste this in. And what they did was they put brackets over here saying insert your letter code. Well, I know for sure our letter code is going to be US. If somebody's not in the US taking this class, then yeah, you would have to put your country information in there. Then we need to use the in quotes. And I would want to say, well, what's my SSID, right? So, darn, I forgot my network already. So I am Dogeden or Doggy Eden minus 5G, right? I'll just tell everybody in the world that. Doge Eden Doggy Den minus 5G. There we go. And then I've got my little password here. But, you know, boop, 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 I'll put that. And then I can save this on my computer. But what I really need to do is file, save as, and send it to that boot partition. And save it on that boot part of the SD card. So, and that's the deal. So we got those two things happening, and that allows you to then take the SD card from your computer and put it into the Raspberry Pi and then boot up with it. And when it boots up, it's actually going to be on the network and you can access it remotely. So we'll stop here and I will get the next section going. On to the next step. We have a Windows machine that has the SD card put into it. So let's just make sure of that. I hit explore here. And there we go. I'm exploring. So I'm looking at the boot. There it is, boot E. Also, when it inserts, it actually says, hey, there's an unrecognizable drive. Do you want to format it? The answer is no, don't format it, because that's actually the full part of the operating system. We're just concerned with getting boot right. So the boot piece here is what we're working on. And I was looking through it, and it doesn't have ssh.txt, and it doesn't have WPA supplicant. And so I'm going to set those up, get them on here, and then the next step will be booting up the card itself and changing the name of the system. So what we're going to do right now is I'm going to minimize that. I'm going to go do a little bit of internet search real quick. So if I do my search, it's going to be Raspberry Pi headless. You know, because I really want people to be able to home back to the resource that's available, and this is an excellent starting point. So it's that we need to create a file like this one, the WAP supplicant, and we need to create ssh.txt. So we know those things for sure. The other part is when I'm doing coding and other things, I like a tool called Visual Studio Code, and it's a darn good editor. And so I'm going to click that over here, and Visual Studio Code is available for Mac, Linux, Windows, and Raspberry Pi now. It's super, super helpful. And it's a good way to like not have your file extensions messed with. This is something that Windows does occasionally, is not allow you to get the names of things the way you want them and throw different things at the extensions. So anyway, what's the story? All right. Okay. So I have it downloaded on here, but this is how you would get it. You would start it up and get going. So now what I want to do is, well, I have it installed right here. So why don't I do this? I'm going to Visual Studio Code running, does a little bit of updates in the background, you know, saying, oh, it has updates regularly. So there's no big deal to just restart and have those updates available. It's always good to get freshened copy of your Visual Studio Code. Okay, so we need a work area, and this little symbol here is about opening folders. So I'm going to open a folder and I'm going to go to documents. I need a spot, and I should probably have a new folder. Control Shift N, and I'm going to call it RPI-headless. Headless. There we go. Headless. Okay. And that's the folder I want to use. So I'm going to click out of there and select headless. So now when I open this folder, it'll show no files in it, but I need 2 new files. So according to the instructions, that's fancy. So according to the information, no, that's a, oh, sorry. I'm running 2 computers at once here, and I'm using one of the remote control programs called VNC to VNC into my computer that has Visual Studio Code and an SD card reader. So, all right, so I have memorized what we needed to do, but what I wanted to do over here was go back over and I guess let's go to this one, and we're going to say Firefox because that's what I was using. And I typed in RPI headless. These are other queries that I want to do because we're going to do VNC later. That's virtual network communication or connectivity. All right, setting up the Raspberry Pi headless. So we need this one file. This is the one that's going to set up our wireless. So the way I do this is I just grab and copy this one, and I'm going to pop back over to the studio code that I set up. And actually, looking at this, I had a few different ones, but one of them was telling me I really was in the headless folder. There we go. Okay. So I'm going to paste this in, and it has all of this information about where all this stuff is and all these things. But the important one is I need to set up US here. And for me, I need it to be Doug Eden -5G. And then over here, I need my excellent password or random router password. So sometimes you get like a number for this. Sometimes you get something really great. You have your own custom one. It could be almost anything, but that's the deal. And when you hit Control S for save, we're going to save it not as a plain text file. We're going to save it as I think we have to do the trick of calling it an all file. So there we go. And this one's going to be called WPA_supplicant.conf. And conf stands for configuration. And then, of course, is it 1P or 2P? So, like, yeah, well, let's go find out. Let's refer to the document. And the document says 2Ps. All right, good. So I will flip back over. Boop. And there's where my work was. Okay. And we're going to save it. So I'm going to save it locally because this way you can always go back and edit it or change it. It's pretty easy access. And the other file that we need is an ssh.txt file. So I'm going to hit Control N. I'm going to make a new file. And this one, I don't need anything on the inside. I just need the file name. So ssh.txt is okay. Sometimes SSH is just fine, but because of the madness of Windows, like if I didn't want the extension, I'd have to call it in all files. But this one can be either way. So if I did it this way, right, it's going to throw the text extension on. So why not? We'll just do it this way, and we'll be Windows friendly. Okay, so now these two things need to be saved onto that boot thing. So one way is to just copy them. So why don't I fire up an Explorer or something, right? I think I had one of those running before. So here's my boot Explorer. And I created this RPI headless folder. So really I want to take these two files, Control C them, or drag them even, to my boot. And over here in here, I'll hit Control V, and that should paste them over. So now I've got the two pieces. They're all set. And really, that's that. We should now take this card, eject it from our system, and put it in our Raspberry Pi. So here is the fun stuff. I will There's an eject, right? There's an eject. So this way it's ejected, nothing's being used, and it's done. Safe to remove. Cool. Now we are ready to boot up our Pi. So that'll be the next section. All right. Well, this is the autonomous vehicle, and that's the Raspberry Pi. And we have the information about what's going on and are you in autonomous mode, feedback for the human, set up in the tailgate. Then I have camera over at the front here. But what we're trying to do is get this Pi booted up as your autonomous vehicle. So that means we need our SD card. And the SD card goes into this little spot. Okay, classic, right? Everybody's gonna do this. We're gonna drop an SD card somewhere and have to find it. So let me try this again. So the tricky thing is we gotta get underneath, right in there. So depending on how you hold things, you just kind of have to feel around for it. And so I just got it, and it slides in. There we go. That's it. So it's easier to pull out, but find the slot, get it in there. So I'm gonna just kind of look underneath. See, there you go. That's where the SD card goes. And we have power. So the power is hooked up here, and it's going to run through, and it has what I would say is a power button. And the power button turns the whole thing off and on. And as you trace this around, you come back to the back of the car, and there is a buck boost converter that keeps the power going to the Raspberry Pi at 5 volts. And as I keep, say, swooshing around here, we get to this junction, and the junction goes down into the car, and that's where the battery is. So this is actually going to be a battery powered car / computer. So I got to flip it on its side so you can see better. So right there is where we're going to plug that battery into. So 1 second, and I will have that battery ready to plug. All right, look at that, a battery. It's got its sticky still on it. None of that really matters too much. But as you can just clear it up. So what you want is a nice rectangular solid battery here. And let's see, it's all packaged together. It's got its caution information. So there's going to be a section on just making sure how to charge and treat your batteries. This one's already charged up to nominal voltage. And what that means is it's basically in a good space to go. Now I'm going to read through this really carefully. It's 2200 milliamp hours. So that's the capacity of this battery. So when it drains, that's the milliamp hours out of it. It's got a thing called 50C. So it can pull something like the C rating. And I think it might be 50 amps. I can't remember exactly. But it pulls a lot of energy very quickly. So this is great for running motors and things like that because it just pulls it. Or for quadcopter, right? You're running 4 motors off a quadcopter. Our car's just running just 1 motor, so it's not too bad. And then the other part to look at is the fine print. It's 2S1P. That stands for 2 in series, 1 in parallel. So what it is you can't see through here too well, but there are 2 packs of batteries. There's a battery pack on top, battery in the middle, and it's sandwiched together with the shrink wrap. And this one is 3.4. The other one is 3.4. At the minimum voltage, that would be 6.8. But what you see is it says it's 7.4 volts. That's the basic charge of this. Now, the range that this charge is down to is 6.8 minimum. If it gets below that, this thing can get puffy and get into a bad state. And if it gets puffy, you want to return the battery to the school, or return it to whoever, or treat it, just get it out of system, because puffy batteries means that something quite went wrong. You can't trust it quite so much as you would like to. Now again, 7.4. If I divide that by 2, right? That should be 3.7 or something like that. Yeah, so there's 2 packets, 3.7. Long story short is you want to pull it off when it's low, but when you get it charged up, it'll be actually 8.4 volts as the maximum. So anyway, we'll go into details about that later. But anyways, 2200 milliamp hours. It's basically 7.4 volt 2 lithium cell battery pack. So 2S is 2 cells in series, and 1 in parallel. So what this does is it's like doubled capacity. And so 2 cells. 2 times 3.7 gives you 7.4, and there's 2 of those, which then gives you total. What it does is it would have been 1100 for the top pack and 1100 for the bottom pack, and because they're in parallel, they're 2200. So anyway, we have a special charger for this and in charging instructions, but that's not what we're here for right now. All right, what we want to do is say, can we boot up our car? So our car, our slash computer, we can boot it up by just plugging in right there. So I'm just gonna grab this, and we're gonna push this in. Yeah, and now it's in. And actually, it's kind of nice because it has like a little spot you can tuck it away in here. So right now, I'm gonna just do a little change the car, right? The car on its side, and I'm gonna zoom back out so you can see better. So it has like a little battery pack slot, and you can just slide this in, and so you move it around, tuck it. Basically, just get it tucked in there, and you're all set. So I'm just moving things in different ways. But yeah, so right now this is not sort of our permanent setup. This is just our quick setup, because really what I want to know is that now that I had put the SD card in, right? I put the SD card in on the other side. Let's get this turned around. There it goes. Okay, so there's the SD card. I got the power in, and like the power button's over here. So let's see about clicking the power button. Yep, that turned on, and look, the light's on. Our car's booting. So this is what's supposed to happen here. I'm going to look at the lights, and what normally you'll see is like a little red light for power, and there's a little green light for if the SD card's being read. So anyway, so it's red with a little bit of green flickering, and then it does stop. So it doesn't flicker all the time. It only flickers when it's reading data, but if it doesn't have to read data, why would you do that? So anyway, this is how you boot the thing up. And we're going to go and take a look at some diagnostic modes, but really our major step here is now, how do we get onto remotely? Our previous step was WPA supplicant, getting SSH working. That's on there. It's booted up. So now we'll go back to the computer and we'll try to get on this thing in a headless mode. So what we did was get the, well, we made our SD card, we put the SD card on, and we booted the computer. Now, the stuff to know is that when the computer boots up, it has a default name. We didn't change anything about what the computer was called, any of that stuff. So what is the default name? Well, it's Raspberry Pi.local. So I'm going to take a thing here. I'm just going to type it in. Raspberry Pi, Raspberry Pi.local. That is what our computer is called. But we need to change the name of it. Right, so this is going to be mine. I think you guys all might have, say, cars with already some names and stuff in them. And I'm going to call this one, what am I going to call it? I'll call it Doge Racer. Doge Racer. There we go. So that would be the name that I want the car to be called, but I know it's Raspberry Pi.local. And there's no period at the end of that. Let's clean that up. All right, so we've got this information about what we want it to be called, and we want it to get that. I'll put .local here too because I'm so used to periods. All right, so this is a little quick note. Okay, Dog Racer, that's what we want to call it, but we got to get to the Pi to do it, and this is where I usually use SSH or VNC. So I'm going to do putty. And in here, I'm going to have to add how I'm going to get to this thing. Well, there's a bunch of next steps, which is that the Raspberry Pi computer has a default username. They all have it. It's called pi@raspberrypi.local. So what that does is it sets it up for us to access through SSH. Tells it what user at the machine you're trying to connect to, and if it's there, if it has booted, we're going to be able to connect to it. I'm crossing my fingers. Yeah, because sometimes when you try to boot up a system headless, it may not boot, and you'd have to figure out why. So there's a couple of things that can happen here. I was trying to boot it up headless for the first time, and it gave us some issues. So this is where we're going to have to actually do a little bit of work about editing that card, getting some stuff changed. So give me a moment and we will be back at it. All right, we're back at the car. We got my SD card updated. So I'm just going to have to get that in there. And of course, it's easier for me to use one hand versus another. So let's just figure this out. Wiggles. There it goes. Now it's set in. Sweet. All right, now keep an eye for little lights over here. I'm gonna hit the power button. And it's giving me that information that it's just, I didn't see any green lights. So we're gonna have to do a little more troubleshooting. So the troubleshooting next is, we had a problem with one of the cameras in the past. So I want to find out, is the camera going to be a problem? So I'm going to unplug this wire, which is the camera. So like getting used to setting things up, this is actually a pretty good step. Of course, we're first going to have to power stuff off. So I'll power that down and then I'll take this out. But I'm going to do a little check first. So coming back soon. This is one of these really important areas. We made the SD card. We did everything the right way. We went over to boot it and we're going headless and it doesn't want to start. And this is just default, like out of the box. So we got to do something here to make it a little bit more happy to do its thing. So this is also a known problem. So we're gonna go out here on the we're gonna keep traveling through. It says, hey, remote access, no keyboard or monitor. Well, there's a number of ways. Let's click here. So I've got the IP address of the computer. Okay. We want access over the internet. VNC is remote access to Pi Graphicals interface, and this is the holy grail. This is what our goal is to get to that VNC piece. The other is SSH. This is just our safety net. This is the command line way to get to the system. But for some reason, if you can't get to the system, and I'll show you, I've recreated the problem just for us, is if I type in putty over here, and there's a little bit of a rabbit hole on this stuff too. Oh, this one doesn't have putty. Okay, but I'll show you something neat. If you don't have putty, you're not out of luck. If we do the command line CMD, that gives us a little shell. So we're now looking underneath the hood. I can do SSH, and look at that. SSH is now built in, so I don't have to use a third party like putty, but putty's a pretty neat program, so it's a good one to have. Now, normally I'm going to do pi at raspberry pi.local. And if our computer booted up and was working headlessly, we'd be on it right now. Now, Windows has this really crazy thing where it doesn't always recognize the .local extension. So sometimes you have to do pi at raspberry. So we're just going to do that. And right, it's not showing up. And there's another command called ping. And ping tries to tell me, is anybody home? Sort of like a submarine sends out a ping. Raspberry Pi.local. And, you know, we're not gonna get anything. And then, like, you know, if it was Windows giving us some weirdnesses, then that would be a thing. Okay, so now what's going on is, in the little video, I didn't see the green light go, which means it didn't read from the SD card, so it's waiting for us. So, okay, well, it's waiting for us. What do we do? Okay, well, we're gonna go on a, you know, that side adventure that I was talking about. All right, I'm back, and what we did was put the card in, booted up the car, looked for the green lights. I didn't quite see them, but I always want to double check my work, right? So double checking my work. Oh, up arrows, go back through the history, down arrows, go there. So I'm going to double check my work. Is there a Raspberry Pi? I'm going to go ping it. It said nope. Is there a Raspberry Pi.local? And we're going to see a nope. All right. So that means we go back to the car, and I was doing that camera testing. So I'm going to do the camera disable and re-enable thing and see if, you know, if that's where our trouble is. we're back at the car. I got to take the power, click the button, power is off. All right, and I want to take the cable. So what it's got is it's got these little edges. Just wiggle them a little bit and they pop. Just a teeny little pop, not too much, because what happens is it just needs to come up just a bit and then come up a little bit and the cable goes. So you can see this has just a little tiny bit of motion to it. I get my fingers this way and it just pushes up and down, but the silver part, the wires of the cable go here and the back goes to the back. So it's just the blue tab, but yeah, here we go. So basically that goes in here just like this. Now we're taking it out in case our boot issue is because of a camera. So I'm going to come back in. And that's telling me, I'll turn it off. All right, and I'm going to say, all right, is it because of this cable over here? So we want to find out. So I got to wiggle this off. There we go. And I should be careful because you don't want things touching. So it's all good. Board's all by itself, and we're going to fire it up again. And blammo! Look at that. So the Pi actually has booted. That little green stuff. So what's going on is we troubleshooted the camera, then we troubleshooted this little additional adapter. So I'm going to have to look into that adapter next. But what I want to do is find out, will this boot with the camera on, right? That's our really important thing. So now that we have access to this, I got to pop over to the computer and actually do my remote access and figure things out. So let's pop over to the computer. All right, so what I'm doing right now is I'm going to turn off the Pi and got it all shut down. So what I need to do is put this back in so I can get this wiggled. But I also need to loosen this guy. Both pieces need to be up a bit, and you can see how they wiggle. So now they're both up. And of course, when you do stuff one-handed, it's a little trickier. There we go. So you can see just how that's set. And usually pressing with 2 fingers gets this wiggled down and tight. Do this. And that. It's a little bit off, but that should be fine. And in fact, we're going to do the whole test. The idea is I'm going to boot this up. Saw that green flash? We're great. The camera and everybody is happy together. So that's super cool. I'm going to turn it off before we go too far. So that would mean our troubleshooting process is like, okay, we've got this guy hooked up, and where did what happened next? So if I flip this around this direction, I'm gonna take it that way, and then if I turn this on, I get my green lights. So the information here is the red wire has to go towards the Ethernet jack for this configuration. So the red wire by the Ethernet jack, and then the connector over here, the red wire is going there. And what I'm looking for is a little tiny shiny light there. Okay, good. So here we are. This is much better. So the vehicle has all of its main parts hooked up. Our SD card is in place. We are getting a boot. All of this stuff is super cool. All right, and then it's just going back to the computer. Okay. Well, we did our test, and I saw the green lights when I unplugged a piece of the car. So, all right, this is our diagnostic process. So I'm going to say, hey, did I find Raspberry Pi.local? This is double checking the thing. Oh, I know what. I also made a password mistake. I typoed a thing in my password. I remember this as opposed to being able to check. So being able to check is to load it back on, make the change, and put it back there. So in fact, I'm going to shut it down and bring it back over, edit my password again, put the card back, boot back up, and we'll see these tests being better. Set up the username password business. So I'm just going to take that off. But it would be dog Eden, then the password. And I had to take this from a working version. It's got update config country US. Okay, all that looks good. So there we are, fresh. The SD card is in the car. The SD card has booted up. We'll watch the little blinking light. So we got red for power. We had the flashing green that was actually reading. So now we need to get to the command line again, and we need to get it to do something for us. So let's do, I guess I'll do search here, and I'll say CMD. So this is one way to get the command prompt. And what we want to make sure is it has SSH. And the other part is there's a command called ping. It's like a submarine sends out a ping and radar, and if there's something that reflects back, something is there. If it doesn't reflect back, it doesn't, so nothing's there. So in our case, our computer is still called Raspberry Pi, and I want to make sure we're going to try Raspberry Pi.local. We're going to send a ping, and then if it gives us information back, and it does, look at that. So it says Raspberry Pi.local. It gives us a reply from, and some pretty good data there. So that's really nice. That tells us that we really have a computer that we're looking for. And then I was talking about SSH before, that's secure shell. And to really like do the next step, we need to do this over SSH, because it's that, or you put a monitor on the computer. So I'm going to do this pi at Raspberry Pi.local. And here's the thing. These are, the username is pi, the @ symbol says what machine, so pi at Raspberry Pi.local is now the car. But all Raspberry Pis, when they come off the default image, they're all going to be Raspberry. That's just how they're going to be called. The username is going to be pi. And then, of course, there is something to know, is that I do this all the time. And so what happens is, it has a host file, and it says, oh my gosh, this host has been changed. Something could be going on. And in fact, the host was changed, but it's a brand new Raspberry Pi, but it remembers the last one I talked to. So I need to fix a file. I need to say, hey, this entry inside of this file is a thing. If it's the very first time you've ever seen it, this isn't a big deal. But because I do this all the time, this is kind of, it's sort of a worrying situation. But we don't have to worry about it too much. So I'm using VS Code, so I can do code. You can either delete your known hosts file, or you can do what I'm doing, which is I'm going to highlight, right click, paste in, and do code the location of that file. And look at this. It actually has, I have like RickCam and all these other things. And look, here's one called Raspberry Pi that it knows about. Here's one that's Raspberry Pi.local. So I want to, in this case, I'm just going to manually edit it and take out those Raspberry Pi entries and save it. So you can erase this file, or you can just do what I did, was just take the entries out. So I'm going to minimize that again, and I'm going to go back to the command prompt. There we go. So hit enter a couple times because that's fun. All right, so now hit back arrow. That's what I want. Code, up arrow, SSH. Yep, there we go. And it's like, hey, we never saw it before. And you're like, yeah, let's take this one. And boom, we're good to go. Now, the password for all Raspberry Pis is Raspberry. And there you go. So now, since it's super default, we got to pick a new password, because anyone, as soon as you put this on the network, anyone can use this information to get onto that Pi. They happen to be faster than you, you could have a whole Pi set up and the password changed before you know it. So you want to do this like on your own network with not other people, but you really need to go in and change the host name, which is the car name for us. You need to change, not the Pi user, that's fine, but you do need to change the password. So these are all things that we can do with different commands, but we can do it all in one place. So I'm going to introduce a command called sudo, S-U-D-O, and it stands for super user do. So the root user, the super user, like, it just gives you temporary powers to do anything you want on the system, anything bad or good, delete files, delete your configurations. There's a lot of power that sudo lets you do, but it takes a regular user and gives them extra powers. In our case, we want to configure the computer, because it's like not every user on your machine would you want to configure your computer. So in this case, sudo raspi-config. So sudo raspi-config. Sudo raspi-config is what we're looking for. So there we go. So now it's a text-based little program, and we're going to run through a few options. We already did the wireless LAN setup by editing the WPA supplicant file, so that's done. And we talked about password, so you can just go there and select, and it'll give you the opportunity to make a new password. So I'm gonna pick the password that we agreed upon, and if they don't match, then it'll say, hey, type those again. They do match, all that. The other part is they won't show it on the screen. So like, for instance, you wouldn't be able to get the password that I changed it to because it didn't show it on the screen by using screen recorder. Maybe a keyboard logger would grab it, but this is pretty safe. So you've changed it and we're good to go, and people didn't see what the new password was. But because we're doing it for Classroom, we have a shared password for the moment, and that just gets that rolling. So we got that part. So system options, we still have a few more of these to work through. We talked about host name. So this is a way to change the host name manually, and it fixes it up. So that's where it was. It was called Raspberry Pi, and the host name is going to be something else. So I could call this Bergen Racer, just for fun, right? There it is, Bergen Racer. So every time, instead of Raspberry Pi.local, it'll be bergenracer.local or just Bergen Racer. So that's the name of the computer now. I still have a few more things to take care of while we're here. Boot. So you can change boot sequence, you can change the network, you can change the splash screens, change the behavior of the power LED. That's pretty interesting. You can't change it here, which is fine. We don't want to change the power LED, but we do need to go, like, we don't need to worry about display stuff right now. We were okay. Interface. This is really important to us because we have a camera that we need to enable. So yeah, you use the arrow keys and the tab keys and the enter key. So I'm going to tab, enter, arrow, yes. Boom. Camera interface is enabled. We've got to do this again. SSH. When we put that file ssh.txt or SSH on the boot thing, it enabled that. We were good to go. So we don't have to worry about it. But our most important thing is this thing called VNC. So our virtual network connection, or virtual network control, sorry. This allows us to have a GUI interface. So what we did was we were talking to it over a text interface here, but what we want to do is treat it like a remote computer that we virtually control. So VNC is the way to go, and we'd say, do we want that server enabled? We'd say yes. Now it sets up the symlinks, and it says the server is enabled. Sweet. All right, so I went here, interfacing options, we got cameras, all that, we're good to go. Localization, well, this is another important one, but we're gonna kind of do this in 2 stages. I'm hoping the VNC stuff all works right and we get into the GUI interface next. And once we're in that interface, that will let us do things like configure the computer, because that's what we're doing. We're really building this computer, we're getting all the parts and pieces in the right place. And now I'm pretty well set, so I'm just going to hit finish. Boom. And we reboot. Okay, so it's one of those deals. You can look at the thing and you can see the red light saying that it's on for power, and you see the flashing green. The flashing green will stop, and then the flashing green will start again. And I mentioned that ping command, so why don't we use ping and see, like, is it back yet? It boots pretty quickly, but it takes a little bit of time to reboot, so we're just gonna ping it and see if anybody said hello. So and I'm just clicking. All right, I'm gonna do a power down manually real quick. So I powered off the Pi, Let me come back here. Click, and I'm going to watch the boot information. So red light went, the green light is on, green light is flashing, and it's moving through its boot steps. So let me go back to ping again. Well, it's still, see, it takes, what it's doing is it's not only booting up to that one screen, it's booting up to the graphical screen. And I'm watching it read from the SD card, little green flashes on it. It's getting a little further. And it could be a 30-second boot time. So here I am, kind of padding, trying to see, you know, what's going to happen here boot-wise. I can say, well, hey, do we have Raspberry Pi versus this one? Okay. So we're getting somewhere in the boot process. I didn't change anything out of default here. So everything here has been plain vanilla stuff. So, okay, now let's escalate this a little bit. Let's say maybe it did work and I need to get to VNC. So I'll click over on my VNC thing here. We were at Raspberry Pi.local in the past, but I believe we are now Bergen Racer. That's right, Bergen Racer.local. So let's start with that. Well, try to connect to Bergen Racer. Oh, look at that. It totally did. Okay. And then what this does is it wants to say, are you a real person? So the catchphrase Mayday export event at a Erosion Bazaar duet, that's just a key thing. So like if you ever see these words change or something, etc., it will it'll be a problem. So in our case, we called it pi, and then I have the agreed upon password here. I haven't remember it, but anyway, it's using that pi user to get in. Currently not show. Cannot currently show the desktop. Well, that's fascinating. So this is one of these things where I did it as if everything was 100%. There's never going to be a glitch, and you know, when you see what we were seeing, there's always a chance at a glitch. So let me think about this. So I was on this machine, and I was remote controlling from it. I want to go back and look at that ping business that we set up. Because, oh, well, you know, here you go. So, I mean, yelling at myself going, well, we called it Bergen Pie. There we go. And bergenpie.local. Oh, no. Okay. Let's try this again. Bergen Racer is what we called it. You actually have to use the name. So, you know, I'm diagnosing things before they've even had to happen. There we go. Bergen Racer really showed up. And ping Bergen Racer. Yeah. So, Burger Racer, Bergen. So you're really seeing, like, this is the stuff that happens to me all the time. So those are the sort of pathways that, like, you go down if things go right or wrong. So some of this is a little more right than I expected, and some of it's a little more wrong than I expected. But here we go. We got the right name. Our pings are telling us stuff. And if I wanted to get to the machine remotely, I just do SSH pi and then put the @ symbol in, and Bergen. I'd say yes, because it's brand new again. We've never been here. Then we type our password. Boop, boop, boop. All right, cool. Well, we're actually on the racer. And it's that part's pretty nice. I'm using some Unix commands like list files, which is ls. I can say, who am I? I'm Pi. So anyway, we're into the under the hood Unix stuff, which is pretty cool. Now we did sudo raspi config before. So there is we were having trouble with that graphical interface. So what would cause that, right? That's a good question. Let me go back to VNC, because right now it says currently show the desktop. I'm going to close this, and then I'm going to go back to it. So we'll go back to VNC over here. And then we have bergenracer.local. We like that. That's kind of this working. Get our password going. Okay, so what it's doing is it's actually connecting, but it can't currently show the desktop because I think it doesn't know what the desktop is. So this is one of these classic gotchas. We're booting headless, but it doesn't know like what resolution. It doesn't know a bunch of stuff. So let's fix that now. And one way to fix that is to go to display options in sudo raspi config. So display options, hit enter, and it's resolution. And I like the, well, we have 85 and we have 82. These are just mode numbers, really. 1280 by 720, 1920 by 1080. So you could actually do 1080p over the remote control, but I wanna have the data. I don't want it to be quite as much information, so I'm gonna go to mode 85. Perfectly fine. Looks pretty good. Less data, faster response. Hit OK. So I hit that. I set that resolution, and it says, "Do you want to reboot now?" And we'll say, "Yes, we want to reboot now." So I'm watching it. The red power light is on. The green light is doing all the shutdown options. It's reading the card as it shuts down, turns off, and then it starts powering back up, and it starts reading information back from the card. So remember, we're Bergen Racer, so pinging Bergen Racer will do us a good solid here, right? Because it's not fully booted back up. And what'll happen is it gets its network address first, then it has the ability to do SSH, and then you can do VNC with it. So let's do this. Okay, we're back up and running this way. And I'm going to skip ahead and I'm going to say, hey, did we get our, VNC stuff working using this technique? So here's Bergen Racer local. I'm going to reconnect, and I got to get my password in. Okay. Boop. And boom. Okay. So what happened was it didn't know the resolution. So we just put in a fixed resolution, and from now on it kind of looks at this lower resolution and says, hey, this is our Pi. Now, finally we get to this step, and this step is actually going through the Raspberry Pi desktop system doesn't know that we use the command line system. So we have a couple quick things to go through here. So I'm going to hit next. This is based in the UK. So everything's United Kingdom. We're American English for what we're doing. And I want to pick New York as the time zone. Use English language, use US keyboard. These are all good things. This sets the country, gets all that in place. And it sets location information. So this is great. This is what we want to see. And then this is the part that's a pain in the butt. We already did set the password, but it's asking again. So you can try to skip it, or you can just type in your new password again. And if you need to see it, you'd unhide it. But anyway, there we go. Set up the screen. We're actually okay on the screen. You don't even need to pay attention to this one. The Wi-Fi network, we're going to skip it because look at that. It's already connected Wi-Fi wise. We did that with the WPA supplicant move. So we're in really good shape with that. But yep, there we go. I'm going to skip here. Software update. Software update's pretty cool. I'm going to skip it for now because I'm going to come back to it later in another step because I want to have this completed and VNC working properly. So I'm going to skip here. And hey, your Raspberry Pi is set up and done. So we're like, whoa, cool. So cool. All right. So we have all these sort of like the Thonny Python IDE. We have all like Chromium web browser. And we have a bunch of basics all here. And this is like remote controlled. You're on it from your laptop or from your desktop system. All of this stuff is, working pretty good. All right. So really to kick this all the way through the process, I'm going to reboot again. I want to get a reboot that's clean and no troubles. So here we go, reboot. You'll see it says attempting connect to VNC server. So this is nice. VNC will just try to connect again. And, good news is, like, for instance, if there was a problem, it wouldn't ever come back. But this one's kind of neat because it's going to keep trying and then it'll reconnect when it finally gets that chance. So I'm looking at the looking at the Pi on the vehicle, and it's got the little blinky green lights, and it's moving along, right? So ping was going ping, 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 and anybody home. In this case, it's like VNC servers, like hey, anybody home, boom, and there we go. So we're the Pi user. We've got our VNC enabled. We have our camera stuff going. So this is a very nice image to start with. One thing that I'm going to do as a bonus is the updates. So what happens is sudo apt. So this is that super user do. There's an apt program that's like apartments for software, and we want to update the Raspberry Pi with the latest and greatest. So first we update the database that says what are our releases and all of our information and all the good stuff that we're working with. Let's freshen that up. And yeah, this is good stuff. All right. So it says there's a bunch of stuff that can be upgraded. So I'm just going to do sudo apt, and I'm going to say upgrade. I'm just going to run this because I want all of these nice fun things to upgrade. And yeah, there's quite a bit. So it's always, what is it? It's, this usually, it doesn't break stuff. It's usually pretty decent. Mainly you're fixing security errors, things like that. So it's a really good maintenance activity to do. And I always feel really good when this is all up to date and freshened, and I got all the new bits and new features available. So I'm going to let that run for 1 second, because I'm just going to click over here on the browser. So the browser can run at the same time, which is pretty cool. You've got all this extra memory on this compared to the Pi 3. So one of the things that I showed earlier was Visual Studio Code. So I can do Visual Studio Code for the Raspberry Pi. And this is super cool. So again, there are a lot of built-in editors and tools for us here, but this is the stuff that's really important. Running Studio Code on a Raspberry Pi, because you can now. And look at that. It's basically one installation thing. It calls itself code. So you go sudo apt install code. And what we did over here was we did upgrade. And now it's like at 7%, 8%. It's moving through. So we're doing this upgrade process first. And then I'm going to do that one command that says put Visual Studio Code on here. And then that's really cool because you have the same editor between Windows, Mac, Linux, Raspberry Pi. And to say that is one of the super, super cool things. So I'm going to let that run. What else am I going to look for? I think we're good with this one. So that's what's the next step is going to be. I just need a couple more things. Just a couple other things about this. Preferences has the ability to add remove software. I'm doing it from the command line, but you could do it from here in the add remove space. You can actually hook up printers, do more screen configuration changes if you need, and the visual Raspberry Pi configuration. So we did this all at the command line interface, and I'm just going to click here so you can see you have the graphical interface that lets you do the same thing. So if we need to change the password, change the eraser, you're like, I don't want to boot to a desktop, I just want to boot to the command line. There it is, it's right there. Right now we're doing auto login. You can take auto login off. I think for us in the race cars, that's really much better. Display wise, if you needed to change something to handle your display, the features are all here. Interfaces, so it's camera, SSH, VNC, tick, 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 and you get all of them. And performance wise, there's a bunch of tweaks and tweakables. We're not really going to dig into that too much. It'd be nice to have a fan and some other things for cooling. And we did our localization earlier, so we got the Wi-Fi. All this stuff is done. So I mean, that's pretty nice. We got all those things, but we did them through the command line just to speed everything up. Then programming, the Thani ID is pretty nice. Chromium, VLC media player. This will play lots of different media. Graphics, it's got an image viewer. Raspberry Pi diagnostics. This is pretty cool. So you could check out your SD card stuff. So I can read and write. And we're not going to do the SD card reader, but will it let you run other tests? So of course, show log. Okay, it's just a SD card tester as far as I can tell. Maybe there's some other stuff here. Somebody finds that out, that would be really cool. But the fact that you can run diagnostics is also pretty good. Now look here, we're at 98%. So I have a pretty decent internet connection, so you know that's moving along nicely for us. And look at that, it's done. And so here's the final awesome thing for this little session. I'm going to go sudo apt install code. This is going to be funny. Apt is a shortcut for apt-get. And sometimes things don't all do what they're supposed to do. Ooh, okay. So why will it not install that? We followed some directions over here. So this is the, of course, everything is crazy. The upgrade code. Oops. We already did this one. I'm going to do Control-Shift-V, which is paste. We did this. Oh, look here. That's the Microsoft repos that we needed. So I think it didn't fetch those in this update. We were like, the default image is one update behind. So now we updated one more time. And I bet you, because we did that update there, we're going to be able to do that install. I'll go back to here. Because it needs to know about it, and then it can do it. So there we go. So it actually is grabbing Visual Studio Code, and its shortcut is called code, as it's the code name for its editor. And there are times that it just has some great features. It can run JetBrooder notebooks. It can edit the code for our projects. So for the FooCars project, we'll be able to edit the code and keep track of things and basically do some of the stuff we were doing in the web browser, but actually in the editor. So that's kind of cool. Yeah, and there we go. Boom. So let's look here. So if I want to go to programming, it says Visual Studio Code. And look at that. Visual Studio Code is on the Raspberry Pi. And I can open up folders. I can add software. We can set this up for Python. It's all here. So anyway, I just wanted to get that going. So what I would say is this is like the Pi is in good shape. And we've got a code editor on here. We have the things that the car needs to know about, the camera, all of those things are on the system. So everything from this point will be a separate section where we're going to talk about how do you set up the code environment for the car. So we're going to stop at this point, pick that up later.